picture this. You're sitting in an immense sports bar or maybe a massive stadium concourse.
Oh yeah, screens everywhere.
Right. And you've got dozens of 4K streams going at once. Every single game is playing flawlessly on a different screen. And, I mean, if you tried pushing that much raw video over a standard network, the whole system would just melt down.
Oh, completely. The buffering would be unbearable. I mean, the sheer volume of data would crash the entire network architecture way before halftime.
Okay, let's unpack this. Because the reason the game doesn't freeze right before a touchdown, well, it comes down to a very specific piece of rack-mounted hardware.
Right, something hidden far, far away from all that visual chaos.
Exactly. So today, we are taking a deep dive into the engine running these massive setups. We're looking at a fascinating catalog from an AV equipment distributor, HDTV Supply, and specifically, we're focusing on the Vitec AVSTR-T T5320 transcoder.
Yeah, because if you're trying to push, raw 4K video, you're dealing with incredibly heavy data payloads. It's just huge.
Yes.
So the Vitec transcoder solves this by basically intercepting those feeds and transforming them in real time. We're talking up to 4K resolution inputs.
Wait, and it handles, what, like 40 concurrent channels at the exact same time?
Simultaneously, yeah. It's a powerhouse.
That's the part that really caught my attention. It's almost like a hyperfluent UN translator,
Oh, I like that analogy.
Yeah, but instead of just changing the language, it's instantly summarizing a dense 1,000-page novel into, like, quick bullet points for a mobile phone.
Right.
While simultaneously reading the full, unabridged version for a giant video wall. So it's actively changing byte rates and altering codecs, like shifting between H.264 and HEVC, just on the fly.
Exactly, to match exactly what each specific device needs. And, well, what's fascinating here is why this actually matters for enterprise environments.
Right, because it's not just some cool party trick.
No, not at all. It's about extending the reach of enterprise IP video. The overarching goal is keeping users updated, informed, and entertained, regardless of the endpoint they're holding. You need an architecture that takes a pristine 4K broadcast and seamlessly hands it off to a digital signage display, a standard HD monitor, or an employee's smartphone.
All in the exact same second without skipping a frame.
Exactly.
Okay, but wait. I get adapting the feed for different screens, sure, but 40 concurrent high-def channels hitting potentially thousands of devices simultaneously.
It sounds like a lot.
It sounds like an instant bottleneck. I mean, the Force actually says this hardware can stream HD to a practically unlimited number of mobile devices without consuming external internet bandwidth. Like, is this magic or I'm missing something here?
It's not magic, I promise. It comes down to really clever localized IP video architecture.
Okay, break that down for me.
Sure. So instead of relying on brute force external bandwidth, where every single device is pinging a cloud server outside the building, the transcoder does the heavy computational lifting internally using multicast distribution.
Ah, multicast. Right, so instead of sending 1,000 individual streams to 1,000 different phones.
Which would instantly choke the local network, yeah.
Right, exactly. It sends one optimized stream that all those devices just tune into.
Precisely. The transcoder handles all that intensive compression locally, then pushes out that single optimized stream. The internal network then routes it efficiently.
Wow. So you aren't fighting for external internet bandwidth at all.
Right. And you're also optimizing the local traffic because the transcoder has already formatted the stream perfectly for that specific environment. It's doing the hard work before it ever hits the broader network layer.
So it's basically acting as the ultimate local traffic director. But here's where I get a little nervous.
Oh!
If this single transcoder is doing all that heavy lifting for a massive venue or a corporate campus...
What happens if it breaks?
Yeah. What happens if the hardware glitches? You're in the middle of a high-stakes live event and a power surge hits the server rack? Then what?
Well, that is exactly where the fail-proofing comes in. You don't just rely on one box. They use a feature called high availability.
Okay, so like a backup system.
Yeah, basically you cluster two transcoders together using a built-in failover mechanism.
So they're, communicating with each other constantly over the network?
They are. They're paired up in an active cluster. If the primary transcoder drops out because of, say, a hardware fault or some random network glitch, the secondary unit instantly recognizes the drop.
And just takes over.
Takes over the processing immediately. It provides continued availability of the live stream transcodes, ensuring the feed never actually dies on the viewer's end.
Wow. It's just a seamless handoff.
Exactly.
Well, That is incredible. So the next time you see flawless video distribution across dozens of screens in a large-scale venue, you'll know there's some heavy-duty processing working tirelessly behind the scenes.
Yeah, keeping the network alive and ensuring the game stays on without a single hitch.
Absolutely. And, it really leaves you with something to chew on.
It does. I mean, if enterprise tech can deliver unlimited HD streams locally with zero external internet dependency and automatic split-second failovers today, what does the future look like when this kind of decentralized, fail-proof local streaming architecture inevitably shrinks down into our everyday smart homes?